Hi guys, welcome to this YouTube tutorial video for physical sciences chemistry. We will be looking at organic chemistry and organic reactions. So our topic today will be mainly addition reactions: hydrogenation, halogenation, hydrohalogenation, and hydration. Now here's some notes. So it says that it takes place when atoms attached to the double or triple bond of an unsaturated compound. So first things first, for additional reactions, we will be transforming unsaturated compounds, right? Unsaturated compounds, turning them into saturated compounds. Now let us remember that unsaturated compounds are those ones which have double or triple bonds between their carbon atoms. So it's alkenes and as well as alkynes, but we'll be looking at alkenes more, right? And we'll be turning these into saturated compounds. Saturated compounds being your alkanes. Now remember that saturated compounds have single bonds between their carbon atoms. Now it says that are faster than substitution reactions, and they are usually spontaneous. The way it's spontaneous simply means that most of them won't need any energy in terms of heat, no energy needed, as well as some won't even need a catalyst. Now remember that a catalyst is any physical substance that speeds up a reaction without undergoing a physical or chemical change. So it doesn't take part in the chemical reaction itself, but serves to speed up the reaction. Now firstly, we'll look at hydrogenation. So we'll simply be adding hydrogen atoms to an unsaturated compound. What kind of an unsaturated compound? An alkene. So we have an alkene, whereby we'll add H2. Remember that hydrogen is a diatomic in nature, so which is also a gas. Now the catalyst to use, it's either platinum, lead, or nickel. So we'll be using, let's say, platinum to form a saturated compound, which is alkane. Remember, we spoke about it. For additional reactions, we'll be turning unsaturated compounds to saturated compounds. So for this one, hydrogenation, of which hydrogen is a diatomic, hence we have that H2 there. So now it says that write the equation for the hydrogenation of ethene. Remember those prefixes. You have meth, you have eth. So eth has 2 carbon atoms. Now let's look at the suffix. The ene there simply means it's what? It's an alkene, right? So we are hydrogenating an ethene. Remember in ethene, we have double bond C there. And then each one of these carbon atoms has 2 hydrogen atoms. And then what are we trying to do? We are trying to add hydrogen, which is a gas, to that using a catalyst, platinum. Now we break those 2 bonds. So we have single bonds now. But remember that each carbon atom had only 2 hydrogen atoms. And now what are we doing? We are adding those 2 hydrogen atoms. So we'll take this, one of these should go there. Remember now this is an open bond, and also that one, because we just broke the double bond there. So the first hydrogen atom attaches itself to that, the second one attaches itself to that. So now what did we have? We had an ethene, which we added the hydrogen atom to it. Then what did we end up with? We end up with that. Now what's that? That's an ethane. We took an alkene, unsaturated, added hydrogen, and we ended up with an alkane, which is now ethane. So let us look at the next example. Let's look at the, okay, let us quickly correct this. It's not hydration, it's hydrogenation. So we're hydrogenating heptane now. Hydrogenation of heptane, but remember the one there represents the position of the double bond. Now if we continue with our list, we had meth, we had eth, we had prop, had but, and then hept, which is 5. Remember hept comes from a heptagon, right? So we have 5 carbon atoms there. 2, 3, 4. Let me add the last one here to make more space. And then, but the first one has a double bond because we see the ene simply representing that it's an alkene. So we attach how many atoms? We have 2 carbon atoms there, and here we only have 1, because remember that a carbon can only bond 4 times. So it's 1, 2, 3, 4. 1 2 3 4. This one must attach to 2 as well, so that each one of them has 4 bonds, right? And then from here, remember what we are adding. We are adding H2, right, plus H2, which is a gas. Now first things first, the catalyst, we know it's platinum, so we are going to break that bond there. So what do we get from there? We get 1 2 3 4 5. Now after breaking the double bond there, originally we had 2 hydrogen atoms. For that, now there's a free bond. This one only had 1 hydrogen atom, another free bond. This had 2, also this one had 2, this one had 3 original. Now for those free bonds, we know that this is H bonded to H, so one of these H has to fill up that, and the other one has to fill up the other one there. So we have an H going here and an H going to that one. So what else? What do we have now? We took heptane or hept 1 in. Remember, the 1 represents the position of the double bond. We hydrogenate this one, adding H2. What did we end up with? Unsaturated to saturated. So we ended up with a heptane, which is now an alkane. From alkene to alkane. That's how hydrogenation works. Right, let us move on. Now we'll look at halogenation. Halogenation, lucky for us, it doesn't need any catalyst. It's another spontaneous reaction. But let us remember, what are halogens? Halogens, it's all those elements that are in group 17. Those elements that are found in group 17 are known as halogens. And you must remember that these ones are also diatomic. So for fluorine, you're going to have F2. We are going to have Cl2 for chlorine, Br2 for bromine, it's I2 for iodine, and we barely use these ones. I'm not saying we won't, but the most common ones that we'll look at are those two. So again, you have an unsaturated compound, which is an alkene. You are adding what? You are adding either one of these elements, which are halogens, to end up with the haloalkane. Remember, a haloalkane is also a saturated compound. It contains single bonds, because look at the suffix part. It's an alkane. It's an alkyl halide now. Okay, let us look at this one. It says write an equation for the addition of chlorine to propene. Again, let us remember, we have our prefixes meth, eth, and what? And prop, right? So we have propene, which is 3 hydrogen atoms now. So we can put the double bond anywhere. If we put it this side, it's the same thing as if we put it that side. This one has 2 hydrogen atoms, this one only has 1, and this one has 3 hydrogen atoms. What are we adding? We are adding, they told us that we should add chlorine now. Remember, chlorine is also diatomic, so chlorine, which is a gas. And what this means is that we have a chlorine and a chlorine, right? What do we end up with? First things first, we break the double bond. When we break the double bond, originally this one had 2 hydrogen atoms, this one had 1, then we have this one which had 3. Now we have 2 open bonds now because we just broke that. So 1 chlorine atom is going to attach itself to that bond there, and the other one, which is this one, is going to attach itself to the other, right? So what do we end up with? We end up with something like chlorine as well as chlorine now. You can see this is a saturated compound. Only single bonds exist between the carbon atoms. Now let us go ahead and name that. Originally we had a propene, or you can name it prop 1 in, so that you represent the direction of the double bond, the position, sorry. Plus we added a chlorine gas without any catalyst now. Then what did we end up with? We ended up with something of that nature, which is haloalkane. Now we have 1, 2. You see the position of the first chlorine atom, it's at carbon number 1, the second one at carbon number 2, right? Which is what? It's dichloro what? Propane. So we have 1, 2 dichloropropane. That's the product we get from that. Now let us look at another example. Write an equation for the addition of bromine to ethene, same as that one, but now we are no longer adding chlorine, we are adding bromine. Remember that this is also diatomic now, right? Let us use the structural formula, not the condensed structural formula. What do we have? we have ethene, which is double bond C. Oh, it's only two. Yeah, two carbon atoms. Eth for two. So this has two hydrogen atoms, two hydrogen atoms. Then what are we adding? We are adding Br2. Remember, this doesn't have any catalyst. First things first, we have this now. Originally, it had two hydrogen atoms. Each one had two hydrogen atoms. We broke the double bond. Now we are left with 3 bonds. How do we write this? This is the same as bromine bonded to bromine. So one will go there, the other will go to the other side. So we have Br, we have Br. Originally, what did we have? We had ethene bonding with Br2 or bromine to give us what? To give us that compound. Now remember, this is a haloalkane, so we must first find the position of the halogen. It's at carbon number 1 and at carbon number 2, so it becomes 1, 2. What? Now it's dibromo. How many carbons do we have? 2 carbon atoms, so it corresponds to ethane. Remember, this is a haloalkane, which is a saturated compound. Now that's how you deal with halogenation, whereby you are adding a halogen, group 17 atoms, to an unsaturated compound to make it saturated. Moving forward, now we have hydrohalogenation. Lucky for us, again, hydrohalogenation doesn't need any catalyst. Remember, with halogenation, we also didn't need any catalyst. But now remember what a hydrohalogen is. You know what halogens are. It's those group 17 atoms, right? Your F2, your I2, Br2, as well as Cl2, right? So now these ones are bonded to hydrogen, meaning you'll have hydrogen fluoride, hydrogen iodide, hydrogen bromide, and what? And HCl now, which is known to be acidic, hydrochloric acid. Now it says, write an equation for the reaction between ethene. Again, we have an ethene. From our prefixes, we know that eth corresponds to 2 carbon atoms. So it's 2, which are double bonded to each other because of the E, representing that it's an alkene. This one has 2 hydrogen atoms. How do we know that? We know this because carbon can only bond 4 times. So it's 1, 2, 3, 4 for the first one. 1, 2, 3, 4 for the second one. And what are we adding? We are adding hydrogen fluoride, which is that. So it becomes HF. Lucky for us, we don't need any catalyst for this. First things first, this one had 2 hydrogen atoms as well as that one. We broke the double bond, so now we are left with 2 free bonds. So we can choose now. This one can attach itself to this and the other one can attach itself to that, which won't have any difference even if we had H and F this side. You see, it's still on carbon number 1. The fluorine is still on carbon number 1. So we'll just go with the first one. Now we transformed an ethene to what? We added hydrogen fluoride with no use of a catalyst to get, now this is a saturated compound, single bonds only. But the position of the fluorine, it's on carbon number 1. So it's 1, not sure of the spelling though, but I think it's fluoro, what's that? It's an ethane. It's 1 fluoroethane. The 1 represents the position of the fluorine. Sorry, this is carbon number 1, this is carbon number 2. Now this won't always work, whereby you can just substitute the fluorine in any of the carbon and you get the same answer. Sometimes you'll get problems like this one. Write an equation for the reaction of propane now with hydrogen chloride, hydrochloric acid, right? Using structural formula. Name 2 products. Identify the major product. Now this is where we'll be using a rule called Markovnikov's rule. You don't have to know the law. You don't have to know how to state it. You just have to know how to apply it. It says that when a protic acid HX is added to an asymmetric, now it's no longer symmetric. Remember with the one we had, the first one, this one was symmetric. Whether you substitute the F on this first carbon or the other one, you still get the same answer. Now if it's asymmetric, the acidic hydrogen attaches itself to the what? To the carbon having greater number of hydrogen substituents. This is very much important. So if we look at this now, we have that it's propane. Remember, prop simply means 3, so it's prop, double bond, This one has 2 hydrogen atoms, this one has 1, and we have 3 for this. What are we adding? We are adding hydrochloric acid or hydrogen chloride, which is HCl. No catalyst needed. First things first, we break the double bond. So this becomes single bonds only. This one had 2 hydrogen atoms originally, and this one had 1, this had 3. Now since we broke the double bond, we have 2 floating bonds or 2 free bonds. So now if you look at this, should we attach the H here and have the Cl here, what do we get? It gives us, now this is 2, you see that the chlorine is on carbon number 2, so it's 2 chloro what? It's chloropropane now, if we attach the chlorine on carbon number 2. But we could have done the same thing and say now, what if we attached the chlorine on carbon number 1, which is now Cl, and then we attach the H on carbon number 2. What happens? Look at the position now. The position of the chlorine matters the most. On this one now, you get 1 chloropropane, right? So which one is correct between the two? According to Markovnikov's rule, it says that if we have a situation like this now, let's say we are still on this. If we have a situation like this, the hydrogen atom attaches itself to the carbon atoms that has more hydrogen atoms. So the ones with free bonds, it's this one and that one. Which one has more hydrogen atoms? It's this. How many does it have? 2. So the H should come here, the Cl should go there. Then our major product is this, meaning this won't be correct. Do you get it? So when we follow Markovnikov's rule, if it's asymmetric now, the halogen should attach itself to the one with least hydrogen atoms, the hydrogen to the one with more hydrogen atoms. How I look at this, I usually call it the rule of unfairness. Think of it this way. If you have 2 friends, friend A and you have friend B, right? Your friend has 2 rands, the other one has 1 rand, and you on the other side, you have 3 rands. Who, between the 2 of them, who deserves a share from your money? Normally you'd say you'd give this one 1 rand, such that now everyone has 2 rands, right? So that you are all equal. But according to Markovnikov's rule, that's not the case. The one with more money receives another, okay? So if you want to donate your 1 rand, it means you will donate to that one, meaning now that person will have 3 rand, while this one remains with the 1 rand, and you'll have 2 rands. So it's the rule of unfairness. The carbon with more hydrogen atoms gets another hydrogen atom. See how it is? Let's move on. Now we will look at hydration. Hydration, which simply means you should add water now. And again, for hydration, we'll be using sulfuric acid, H2SO4, which is concentrated, right? Yes, we are turning an alkene to a saturated compound. But what kind of saturated compound? It's an alcohol now, right? Yes, Markovnikov's rule, we've already spoken about this. The one with more hydrogen atoms gets another hydrogen atom. So first things first, write an equation for the reaction between ethene and water. We know ethene. How to write ethene? Ethene has to be met-eth. So we have 2 carbon atoms, each one of them having 2 hydrogen atoms. What are we adding? We are adding water, which is H2O. Remember, how do we split this? It becomes H bonded to what? To OH now, right? We need that hydroxide group. The catalyst we are using, it's H2SO4, which is now concentrated. We need this because if it's not concentrated, it means something else now. It can be substitution or elimination reaction, right? So what are we forming? First things first, we break the double bond. When we break the double bond, this one originally had 2 hydrogen atoms, and then also this one. So now, either way, if we choose to substitute the hydroxide here and we have the H there, it's the same thing as if we substitute the hydrogen here and have the hydroxide on the other side. This is symmetrical. Whether you put it on that side, it will still give you the same product. So now what were we transforming? We were transforming in ethene. We added water in the presence of what? of a strong of a concentrated sulfuric acid, right? And then to get that substance there, which is what? That's an alcohol, right? Since it's 2 carbon atoms, it has to be eth, but it's ethanol, right? But we can't just say ethanol. We need to also identify or show the position of the hydroxide. So it becomes, it then split 1 ol, right? But it's the same thing as if you say ethanol, because whether or not you put the hydroxide on this carbon or that carbon, it gives you the same thing. Now, if it's asymmetrical, just like this one, it says, write the equation for the hydration of propene. Now, how do we represent propene? Remember, this is 3 carbon atoms. This one has 2, this one has 1, and this has 3. Reacting with water now, we can say it's HOH, and then remember this is H2SO4, which is concentrated to form what? First things first, let us break the bonds. When we break the bonds, this one had 2, this one had 1, this had 3. Now we have 2 floating bonds, which is that and that. Now, according to Markovnikov's rule, on these free floating bonds, the one with more hydrogen atoms receives another hydrogen atom to get that. Yes, so originally we had a propene, but the more appropriate way to write the propene is how? It's prop 1 in, right? To represent the position of the double bond. Plus, okay, let's write it in with plus water. And then to get what? To get this substance here. This is an alcohol now with 3 carbon atoms. So that we'll call this propan 2. Or remember, the 2 comes from the direction of the hydroxide. This is carbon number 1, carbon number 2, carbon number 3. So the hydroxide is on carbon number 2. We also follow Markovnikov's rule whenever dealing with such. So that's it with additional reactions.